Good evening. Do you have any idea what this thing is? No, it's not an amazing new pinball machine, but it is a counter which will actually count up to 1 million in 1 second, and it's just one example of the electronic wizardry that we're going to see tonight.
Success Story, an on-the-spot live telecast, brought to you each week from somewhere in Southern California as a public service by Richfield, makers of a complete line of years-ahead petroleum products. For every industrial requirement, there is a specialized Richfield lubricant. As our technicolization expands and reaches deeper into the mysteries of the physical world, we find our human senses inadequate in coping with the incredible smallness and tremendous force of the atom or the infinite depths of space. We enter a world where subdivisions down to the million parts of an inch are still too large, where speed is no longer measured in the familiar miles per hour, but in Mach numbers. A world where medical science is probing at the very essence of life itself. In such a world, it's no wonder that the ordinary senses, which serve man so well in his everyday experience, soon meet their limitations. However, in this seeming paradox, the human being does have one advantage, for although he cannot perform the tasks, he can conceive and build the machines and instruments that will do it for him. One organization devoted to the task of creating and building such tools is the subject of tonight's success story, Beckman Instruments, Incorporated. And to tell this story, our cameras have journeyed to Fullerton, California, to the new headquarters plant of Beckman Instruments. Here we shall see the manufacture of scientific tools so delicate that in certain phases of assembly, an accidental touch or a single breath could destroy the work of hours. An example of Beckman Instruments is this device known as a Flame Photometer. A typical example of its use might be in any modern hospital. A patient is admitted in a serious condition. Surgery is indicated, but the patient is too weak. A sample of blood is rushed to the laboratory. With former laboratory techniques of test tubes, retorts, and burners, the analysis would have taken hours. Now, however, with the aid of the Flame Photometer, the necessary pre-operative tests are concluded with precision and accuracy within moments. At this point, you're probably asking yourself, well, just what is a flame photometer? Our success story reporter, Ken Peters, has just asked this same question of Jack Bishop, who is general manager of this division of Beckman Instruments.
Well, Jack, I think it's only fair to warn you right from the start here now that you're talking to a fellow who certainly admires but just doesn't begin to comprehend the complexities of this great field with which you people here at Beckman are so familiar.
Well, Ken, I don't think it's really so complicated. I think we can give you a pretty clear picture here.
You really do?
Sure, I think so.
Well, all right. Supposing you try to convey to me just what this flame photometer does.
Well, the flame photometer is used by doctors primarily. It's used in the medical field. And one example is taking blood samples down here where the blood is sucked up into the flame and burned. This instrument measures the amount of sodium and potassium in the blood. Each element gives off a different color, and then the amount is recorded on this meter here, which tells the doctor exactly how much sodium and potassium in your blood, which is very helpful for him in diagnosing your problems.
Well, I can see how this instrument then would be extremely helpful to the medical profession. This next one is a color machine. What is its nature?
Well, this is a spectrophotometer, Ken. This is a sample of a paint chip, which the operator would put in the machine here, and then the machine would operate automatically and tell the operator exactly the color characteristics. It will define very closely various shades of color. It will tell how many blue pigments, green pigments, and reds that are in the instrument. It's used in the paint industry by the people who make face powders, paper, anywhere where you want to define colors very accurately.
Jack, you know one thing, it seems to me the names you get for these devices are enough to scare some people off. For instance, you refer to this as a spectrophotometer. Isn't there a simpler name for that?
Well, Ken, I think you might call it a fingerprint machine, if you like.
Well, that sounds a lot better. Why would you call it that, Jack?
Well, you know how the FBI takes your fingerprint to tell exactly who you are. The chemist uses this machine to tell exactly what chemicals are present in a mixture and exactly how much of them. The instrument draws a fingerprint, if you like. You can see it taking place here. And the chemist calls this a spectrum, and by looking at it, he can tell exactly what chemicals are present and how much.
Well, what different uses would this have?
Oh, for example, a chemist working for a cigarette company can tell exactly how much nicotine there is in tobacco. Or in the steel industry, how much chromium in steel. Mm-hmm. Or, for example, in the pharmaceutical industry, they tell how much vitamin A is present in pills. In fact, vitamin A was synthesized on this machine, Ken.
Well, now, this machine on the end here is one that certainly intrigues me, Jack. What is this called?
This is a 200-channel automatic recorder, Ken. It's one of our industrial products, and this instrument has been built for the Douglas Aircraft Company. It will automatically record 200 strain gauges on a wing to measure the stresses in the wing. It does it real rapidly and automatically. Would you like to see how it works?
Well, we certainly would, Jack.
Here, I'll start it up. And as you can see, it's recording automatically each of the different instruments on a separate card. This used to take many, many man-hours to do as accurately as this machine does automatically.
Well, Jack, I certainly wouldn't say that we completely understand these feats of the electronic wizardry, but I think we've all got now a very healthy respect for the important job that they do.
The instruments upon which Beckman has built its reputation are the result of many trained minds and hands. In this area, women are working on cable boards, preparing the networks of complex wiring that will serve as channels through which electrical impulses will flow to control the actions of scientific equipment. Each board has been designed and marked to indicate the exact position of each wire in relation to all other wires in this series. The insulation on the wires has many colorings to simplify the task. But even with this aid, it requires careful handwork and a steady concentration to see that every wire fits into the required pattern. Some of the more complex instruments for automation controls require thousands of separate pieces of wire of varying lengths, and not one single strand can be out of place. Another vital part of the production of Beckman Instruments is the use of glass. One of the most interesting operations is the preparation of a photo tube.
Well, I don't know about you, but the art of glass blowing always intrigues me, and they've got some very interesting examples of it here at Beckman. Here on lathe number 1, Bob Wilson is forming the outer shell or the envelope for a photo tube. Now, on this side, we have the stock tubing, and over here, he has welded on a smaller tube so that he can introduce air from both sides. And let's just watch how Bob goes about now to form this highly important little tube. Now, there you see he is severing that end and removing that smaller tube, and he discards that. And now he takes a smaller tube yet, which will actually become the stem of this photo tube, and you'll notice how he will weld that into place. Now, this is the stem through which air can be removed in order to make this a vacuum tube. You see how he enlarged the end of that in order to fit perfectly with the opening in the end of the tube itself. And there he has formed a perfect weld. Now, this is a gauge which determines for Bob just where he should begin to sever the top end of the tube there, and that's what he is doing now with his flame torch. Now, while he is doing this, he is also preparing the next tube for the proper shape at the bottom. And then here we'll see now how he'll just remove this excess material, and we'll have the finished tube here. In this operation, he is bringing out the shoulder to uniform thickness. Well, there it is, Bob, and if you'll hold it for us so we can see. I want to point out this is a little window here, which gives an area of pure glass through which the light can penetrate. I want you to see how that little window is formed on the tube. That's done just across the aisle here by Nora Shepley. And, well, yes, we're just in time to see an operation here. She's heating it in the area where she is going to blow the bubble. And here's the act. You can see the bubble rising there. Then she'll put it over on top of this flame, and she can judge just exactly when it is properly inflated to give that effect. There you can see. Could you see the perfect bubble that's been formed? Now, there's another very interesting example of hand glass blowing down here, which I think you should see. You know, hand glass blowing is a pretty rare art these days, and because of the great many different shapes and sizes of tubes they require here at Beckman's, the work of the hand glass blower is very important. So let's watch Bill Mangold in action here. You can see he is turning that manually, and at the same time, you'll notice while he is turning that, he is blowing into this device. Now, he isn't smoking one of those water-cooled Turkish pipes, but he is actually controlling the flow of air into this implement, which is an electrode body. And when he gets at the proper heat there, he'll use that tool in order to shape it to the perfect form. With the use of different shape tools, Bill is able to perform a great variety of jobs. Incidentally, Bill makes it look very easy, but I understand that there are just about 6 men in this entire area who are qualified to do this type of hand glass blowing. Well, now to get back to our photo tube, it's time to go to another department now and see how the wires and the electronic parts are assembled. As a matter of fact, that is being done on the Beckman Thermocouple, which John Kennedy is now ready to introduce us to.
The thermocouple is really a special kind of thermometer used to measure very small amounts of heat in a Beckman spectrophotometer. Some of the parts which make up the thermocouple are so small that a microscope must be used to assemble them. Here are the parts that must be assembled inside the thermocouple tube. We are now looking at Mrs. Oridson, a highly skilled Beckman employee whose intricate job is to assemble and solder the component parts of the thermocouple. Let's join Ken Peters as he finds out more about this stage of assembly.
Mrs. Oridson, do you enjoy working with these tiny parts?
Oh, yes, very much. In fact, I find it a real challenge.
Mm-hmm. Well, now I understand this is a receiver assembly that you're going to make here. Could you show us the steps involved in making it?
Yes, we'll take the small particle of gold and place it on the plate of the
You mean those tiny little specks we saw on that glass are the actual receivers, huh?
Yes.
And you're going to weld wires onto them?
A small wire will be welded to the gold.
The wires are in there? We'll have to take your word for it, because they're so tiny that we can't see them.
I'll place it on the plate.
Then how do you manipulate them around on the plate into the right position?
With the one-haired brush.
A one-haired?
Yes.
Yes, there is one hair there. Is that any special kind of hair?
Oh, yes, it's quite special hair. In fact, we get it from the heads of our distinguished guests and visitors, and we'd like to have one of yours, Mr. Peters.
I guess I could spare one for science. And now this is a little spot welding unit in which you will actually spot weld. I imagine if you sneezed here, you'd be out of business for quite a little while, wouldn't you?
Oh, yes. In fact, we did have a sign in here that we shouldn't breathe in this room.
No breathing allowed.
Now, I have the wire in place, an electrode on it, and all I have to do to weld it is to press this little button and pray.
Mm-hmm.
There it is.
Now,
Would you like
look.
to see it?
Beautiful job, I'm sure. How long have you been doing this type of work?
Well, I've been with Beckman about 12 years, but I've been doing this work about 5 years.
Doesn't it make you nervous?
Oh, not at all. In fact, it's the successful results are a great feeling of achievement.
You never feel like going home and beating your husband, then?
Oh, not for this.
Well, thank you very much for letting us interrupt you, Mrs. Oridson.
You're welcome.
Now I think it is time for us to move along.
Another important operation in the manufacture of scientific instruments is high vacuum processing. Let's watch as a phototube receives the high vacuum treatment. Although the phototube is cleaned and handled in air-conditioned rooms, there are still elements in the tube which, unless removed, would release harmful gases. These gases would lower the vacuum inside the tube and impair its efficiency. Dave Rohrer, supervisor of tube processing, has finished flushing the system with nitrogen to remove the impurities. Then he turns on the powerful suction motors. To further ensure that no useless gas will form at a later date, a curious item called a Barium Getter is employed. A small wire loop of barium metal is mounted inside the tube. An induction heater pointed at the barium raises the temperature to 1,500 degrees, exploding this tiny chemical bomb against the inner wall of the phototube. The chemically active layer now serves as a trap for wandering particles of gas, just as fly paper gathers in flies. The tube is now gas-free with a full vacuum, ready for installation in a precision Beckman spectrophotometer. You are viewing Success Story, a live, on-the-spot telecast from the Beckman Division, Beckman Instruments, Incorporated, at Fullerton, California. Success Story is presented by Rich Field. This is the original Beckman pH meter, an instrument introduced 21 years ago. Today, the pH meter has been dressed up and redesigned, but its function is still the same, to determine acidity or alkalinity. Now, let's join our Success Story reporter, Ken Peters, as he chats with founder and president of Beckman Instruments, Dr. Arnold O. Beckman.
Well, Dr. Beckman, after seeing all of these amazing operations, I can't help but wonder how an organization like this ever got started.
Well, we got started very casually just 20 years ago, Ken. I was teaching chemistry at Caltech when an undergraduate friend of mine came in and told me his troubles. He had to measure the acidity of lemon juice, and he had difficulty with the equipment which was then available. So I built an electronic amplifier for him to help him out of his troubles. He came back in 2 or 3 months and wanted to know whether I wouldn't build him another one because someone else was always using the first one. I decided that was enough to start a business. So we built a commercial model, and in the fall of 1935, I took the instrument across the country to talk to dealers to see whether they thought it would be a saleable item.
And from that little acorn, this entire organization has grown. The pH meter was your beginner. Is it still an important part of your business?
Yes, it's still a substantial part of our business, although, of course, we have many other devices, helipods, spectrophotometers, which make up a large part of our total.
It seems to me, Dr. Beckman, looking around, that an unusual amount of your operation is devoted to research, isn't it?
Yes, it must be. Research is the lifeblood of our business. The instrumentation and automation are so new that obsolescence is a very important factor. What is new today is out of date tomorrow, and we must devote a large part of our manpower to research to make sure that our instruments are always kept up to date and that we develop the new instruments which are needed to take care of the ever-increasing requirements of science and technology.
Dr. Beckman, I know that we have a good number of young people looking in tonight. I think they might appreciate a statement from you as to the possibilities in the field of electronics and automation.
Well, I'm probably a little biased, but I can think of a field no more fascinating than that of electronics, instrumentation, and automation. These fields offer the same sorts of frontiers which our forefathers had in the geographical frontiers, and I can recommend the electronics, instrumentation, and automation highly to any person who has the least degree of interest in these fields.
Oh, fine. Thank you very much, Dr. Beckman. And now, if you'll excuse us, I think we'd like to continue our exploration.
Among the most widely used of Beckman instruments is the Quartz Spectrophotometer, whose use in the detection and the measuring of hundreds of different substances is finding increasing application in research, medical, and industrial fields. It can detect the presence and the quantity of a specific substance in a compound in a matter of minutes instead of hours, days, or weeks. Naturally, this is of tremendous value to all kinds of chemical manufacturers, to bakers, tire makers, textile mills, producers of vitamins, beverages, insecticides, paper, paints, cosmetics. The list is endless and growing. And a vital factor in the range and accuracy of this quartz spectrophotometer is the quartz itself, the small, carefully prepared prism through which light passes and is broken up or spread out into its spectrum of colors.
Well, where does the best quartz in the world come from, and how do we get it? Well, I asked Louise Schur those questions, and she tells me that the best quality of quartz comes from Brazil and arrives here in crates like this, where the stones that vary in size from 5 to 60 pounds are packed together. When they arrive here, they're inspected for any structural or mining faults, and if Beckman decides to come up to their requirements, they buy them. Otherwise, they are sent back to Brazil. To give you an idea what an important item they are in their work here at the Beckman plant, last year they bought $110,000 worth of bulk quartz. Let's see how one of these stones is converted into prisms. Louise Schur here is inspecting one now in this oil bath. The oil is the same refraction as the stone itself, so she's able to detect its internal properties. And there's a Polaroid light that's shining up through the bottom of that tank, which enables her to determine the optical axis of the stone, which she is marking with that pencil. Then when she has that marked, Louise takes the stone over here and marks it for cutting. And Louise, I believe you have this one already marked. Can you tell us how you determine where to put the marks?
We determine our optical axis by first putting our axis parallel with the edge of our board and marking our first cut parallel with the board.
Mm-hmm. And then once it is on the board and properly marked, she applies plaster of Paris, as you can see here, in order to get it secure. And then it's all ready for cutting. And we can see how that is done over here. It is done with the use of a diamond-impregnated circular blade. Now, this cutting is purposely done very slowly and with a generous amount of coolant because they take every possible precaution to make certain that there is no heat fracture, because a perfect prism is the necessity of the end product. It takes about 2.5 minutes to complete a cut on a stone this size. And there you can see how one slab looks. It is then taken over here, and you can see that Louise has taken this slab and again mounted it in plaster of Paris, and then has drawn off this design, the shape of the prism. So it returns to the cutting machine. When it comes back this time, it's in the shape of a block like this. She then makes this diagonal marking, and it is then cut in two, with the result that we have individual prisms. And once she decides that the optical axis is perfect, why then it is mounted and it is given its finish, polishing, and grinding, an operation which I think you might be interested in seeing yourself.
The polishing procedure is a long, tedious one. The degree of tolerance is controlled to the millionth of an inch. Such is the exactness required in a Beckman instrument. After the final cut, the quartz is sized on huge milling machines and grinders. Then the quartz is blocked in plaster and placed on a revolving spindle to prepare it for polishing. To polish the quartz, aluminum oxide grits of varying degrees of coarseness are added from rough to fine, similar to various grades of sandpaper in woodworking. Final polishing requires extremely fine jeweler's rouge. After the element is polished to the exact tolerance, it is sent to the vacuum coating room where aluminum is vaporized upon the desired surface. This is accomplished under vacuum in a bell jar by electrovaporization, similar to the action we saw in the Barium Getters. The construction of resistors, the assembly of wire patterns, and actual building of instruments are good examples of the Beckman tradition of individual control and perfection. Each minute step in the construction and assembly is of major importance. The skill of each worker is a tribute to the final end. Beckman precision instruments play a large part in America's tremendous chemical industry, which in turn contributes to everything you eat and wear, to your shelter and to your household conveniences. From May 16th to the 21st has been designated as Chemical Progress Week, as a salute to an industry that has shown how free enterprise can achieve near miracles and raise living standards to the world's highest. So that we may better understand Beckman's contributions to the key industries of America, let's rejoin Ken Peters and Beckman Division General Manager Jack Bishop.
Well, Jack, I think we've actually learned quite a bit since we saw you last. And with all these amazing operations here, as I understand it, this Beckman division is just one of 6 divisions of the entire company.
That's right, Ken. The Beckman division here builds instruments to analyze chemicals, both for use in the laboratory and in chemical and petroleum plants. Mm-hmm. Now, we have 5 other divisions that also make instruments. And Don Duncan here, who's the general manager of our helipot division, I think could tell you something about them.
Well, fine. We'll turn over to Don then here. Don, the first question that comes to my mind is, what is a helipot?
Well, there's a helipot for you, Ken.
It is? Well, the question still goes, what is a helipot, Don?
Well, the name helipot was formed by putting together the first syllables of 2 words, helical and potentiometer. Now, a potentiometer is about the same as the volume control in your ordinary radio or TV set, except the ones that are made by helipot are much more precise and are made for scientific and industrial uses. Helipot potentiometers form the heart of many types of electronic computers. In fact, we have here a working model which demonstrates how helipots are used in computing bomb directors.
This is certainly an interesting-looking display here.
These 2 knobs control the positions of the ship and of the plane up there. They're also connected to helipots. And through the helipots and a small computer, they control the exact angle of that little plate that you see down in the corner.
Mm-hmm.
Now, if that plate is positioned accurately enough, a little bomb dropping out of the plane will bounce just high enough and just far enough to land right in the funnel of the ship, like this.
Wow! It did.
Now I can change the position of the ship and change the altitude of the plane.
And it'll still hit?
We hope. And it did.
Yes, that isn't amazing. Well, now, Don, this next device is one our viewers will recognize as the one we opened our show with
That's
tonight.
Right, Tim, you mentioned this before. This is a high-speed electronic counter that's made by the Berkeley division, located up in Richmond, California. This particular counter, as you mentioned before, is able to accurately show as many as 1 million counts per second. Right now, it's counting the revolutions of this motor located on top of it.
Mm-hmm. Well, now, we've still got some other divisions unaccounted for as yet, haven't we?
That's right. We have the ARGA division located in South Pasadena, which makes many high-precision devices for both industrial and military uses. One of its products is called a synchro. Now, synchro, like a helipot, is very important to electronic computers. This synchro was one that was used during the last World War, and I think weighs around 10 or 12 pounds. This little synchro next to it is the one that replaces it, of current design.
Mm-hmm.
As you can see, it's many times smaller, yet it's actually more accurate. Among some of the other products of ARGA are these special types of panel meters having expanded scales.
Mm-hmm.
And finally, we have the Spinco division of Belmont, California. Their products are used in medical research. This is the optical ultracentrifuge, which first successfully isolated pure polio virus. This equipment operates at about 60,000 revolutions per minute and produces forces up to 250,000 times as strong as gravity.
Well, Jack and Don, we certainly want to thank you. I feel it's been a real privilege for us to be able to find out something about a little-known but extremely important part of our modern industrial society.
Thus we have told the success story of Beckman Instruments Incorporated. In its shops and laboratories and among its people, we find a purpose that seems to typify the industrial and scientific spirit of America. In a world that is constantly pushing back the frontiers of knowledge, destroying old theories and replacing them with new concepts, we're certain that Beckman Instruments will play a strong role in helping to maintain America's leadership in a world growing increasingly complex. For the research being done here today shapes not only the history of our own nation, but perhaps of the world. Just as these explorations are typical of the American spirit of pioneering and free enterprise, so Beckman Instruments will continue to grow and contribute to our society, all an even greater story in the years ahead. Success Story, an on-the-spot report, is brought to you by Richfield, makers of a complete line of years-ahead petroleum products. For every machine in every type of service, there is a scientific Richfield lubricant. Next week at the same time, we bring you another live origination of Success Story with Ken Peters. Your camera reporters were Chuck LaForce, Len Uslaner, and Bob Masters. Floor managers Buck Pennington, John Richardson, and Lloyd Wright. Audio engineer Frank Daffern. Next week, we take you on a tour of Barker Brothers in downtown Los Angeles. John Milton Kennedy speaking, wishing you a good night from Richfield.